Today's problem is modified adomian decomposition method. Y of x is equal to sine inverse of x plus pi by 2 minus 1 into x minus integral from 0 to 1 x into y of t dt. So today we are going to do modified adomian decomposition method. I'll turn the page. Yeah, so let me start with this. So where I was, okay. So y of x is equal to sine inverse of x plus pi by 2 minus 1 into x minus integral from 0 to 1 x into y of t dt. Now this part is very important. I will be explaining you all now. Now see this, okay. Now you all have to take this part as your what? f1 of x, okay, f1 of x, okay, and this part has what? And this is your f2 of x here. Okay, is that clear? Next, what you all have to do is, right, what is my f1 of x is equal to sine inverse of x. What is my f2 of x is equal to pi by 2 minus 1 into x, this part, okay. Now, what is my y0 of x is equal to? I have solved a modified adomian decomposition method proof, okay, or you can say some, yeah. I have already proved that statement along with the proof. So, in the previous lecture, you'll have to know it very well to know this problem, okay. Now, y0 of x is equal to f1 of x, which is equal to what? What is my f1 of x? Nothing but sine inverse of x. So now I need to find out my y1 of x is equal to what? f2 of x plus lambda integral from 0 to 1 k of x comma t y0 of t dt. Now y1 of x is equal to what? What is my f2 of x? My f2 of x is nothing but pi by 2 minus 1 into x, right? That's what I'm going to write here. Then minus, what is my lambda is given here? Lambda is 1. Okay, there is no lambda. So it is, I'm considering it as minus 1. So, because your minus sign is there, right here. So, minus integral from 0 to 1. What is my kernel given over here? Yeah. So, x, right? Kernel is given as x. And what is my y of t? Meaning, sorry, it's not y of t, it's what it is? Y0 of t. K of x comma t is nothing but x. Y0 of t is nothing but here, sine inverse of x. Y0 of x is equal to sine inverse of x. So, that's what I have written it over here. Sine inverse of x, sine inverse of t, because it is t, no? So, dt. Y0 of t it is, that's why. Now this is equal to what? Pi upon 2 minus 1 into x. Write this part as it is, then minus x. This x I will take it out from the integral because we are integrating with respect to t. Now integral from 0 to 1 sine inverse of t dt. Now what we are going to do is put sine inverse of t is equal to u. So if you take sine this side, what you will get is t is equal to sine of u. If you differentiate this, d with respect to dt is equal to cos of u. This is what sine of u is nothing but cos of u into du. Okay. Next is what? y1 of x is equal to what? Pi by 2 minus 1. So write this. Pi by 2 minus 1 into x minus integral from 0 to pi by 2. So wherever there is sine inverse of t, write this. Sine inverse of t is what? U. That's what I have written over here. Okay, now how you all get this cos of u? Wait, I'll turn the page. Sine inverse of t is nothing but u. And what is my dt here? Dt is nothing but cos of u into du. So cos of u du, sorry, cos of u du it is. So now what is the this part you all have to write as it is. Now what is the integral of this? So for that I need to do, this is the rough page, okay? I have to do the, right, I have written the formula over here. Now what is my u is nothing but u only, v is nothing but u by v dx, integral of this, okay? And v is nothing but cos of u du, okay, with respect to. So u is as it is, I have written, then I will have to integrate this cos of u, then du minus what is this? U dash, and then v is what? Cos of u du with respect to du only. So now this is equal to what? U sine of u. Integral of cos of u is nothing but sine of u minus this minus, and what is u dash is with respect to u, no? So it is 1. So what is integral of cos of u is sine of u. But again you have to integrate this, you will get minus cos of u. Now minus and minus is plus, so u sine of u, right, as it is, plus minus and minus plus cos of u, okay? So what I will get is u sine of u minus and minus plus cos of u, okay? Now, okay, now what you all do is, now substitute this value in this, okay? Wherever integral of 0 to pi by 2 is there, to integral of this, I have to substitute in this now, okay? So y1 of x is equal to pi by 2 minus 1 into x minus x. Write down what was the integral of cos of u cos of u sine of u plus cos of u, and the limit is from 0 to pi by 2. Now what I have done is, what I got is y1 of x, this part I have written as it is equal to pi by 2 minus 1 of into x minus x, this into what value I am going to get of this is nothing but, I will get pi by 2 minus 1, and this is nothing but equal to 0. Now okay, I will explain you all, I will tell you all how I got this part, okay? Pi by 2 minus 1, I have solved this for you all. So u sine of u plus cos of u, no, this part I was supposed to explain how I got pi by this thing, pi by 2 minus 1. Now this is what? Substitute pi by 2 sine of pi by 2 minus 0, upper limit minus the lower limit for this one, plus upper limit minus the lower limit for this one. Now what is the sine of pi by 2 is nothing but 1. But what will remain? Pi by 2 into 1 minus, this is 0. Okay. Now what is cos of pi by 2 is again 0. And now this is what? Cos of 0 is nothing but minus the lower limit, no? Cos of 0 is nothing but 1. But this minus is also there, so minus 1. So what is this? Pi by 2 minus 1. So that's what I have written it over here. And now this implies y(n) of x is equal to 0 for all n greater than or equal to 1. Hence the solution is y of x is equal to summation of n is equal to 0 to infinity yn of x. Now yn of x is equal to 0 I got, hence this is the solution. Next I'll turn the page. Now what is my y of x is equal to? y0 of x. It is like y0 of x plus y1 of x. It's like this, plus y1 of x plus y2 of x and so on, okay? And it is so on like. But the thing is that the value of this is 0 and 0 everywhere, okay? But y0 of x is what? f1 of x. In the first only it is given, right? y0 of x is equal to f1 of x, which is nothing but y0 of x is equal to f1 of x. Therefore y of x is equal to sine inverse of x. So I am done with today's lecture. In the next lecture I will be proving more problem on this.